Let's see how to solve a sample problem on free fall. So we are having a certain freely falling object which is released from rest, that means Vi is equal to 0, and it requires 2 seconds to travel the last 40 meter. Okay, that's important to read. It is saying 2 seconds to travel the last 40 meter before it hits the ground. So let's draw the ground, and the last 40 meter is covered in 2 seconds. Now we want to find what's the velocity at this point, which is 40 meter above the ground. Okay, now before we go any further, we will decide and we will recall that upward direction will be taken as positive and downward direction will be taken as negative. We know that from before. Why I'm emphasizing it? Because we have vector quantities, which is velocity here and acceleration. They are vector quantities, and also the displacement is also vector quantity. Now it's asking us to find the velocity of the object when it is 40 meter above the ground. That means we want to find the velocity at this point. So we write what is given data. Delta x, which is displacement, is negative 40 meter. You can see that I am writing it as negative 40 meter because the object is falling downwards. Then time and acceleration and Vi, which we want to find at this point, which is 40 meter above the ground. Acceleration, you can see it's not provided in the problem, but we know that it is freely falling, so acceleration will be negative 9.8 meter per second square. Now we will choose the second equation of motion because that is what can give us Vi with the given data, and we substitute the values. We get the answer for Vi as negative 10 meter per second. We can see that our answer has come out as negative. The reason is the object is moving downwards, and we said that downwards will be taken as negative. So that's how we complete the first part. Okay, remember that in this problem we have taken Vi, which is at this position. You can see that this is the position where we are trying to get Vi. Okay, so because we are dealing with the last part, which is 40 meter of the motion. We are not starting to from the first position of the object. We are starting somewhere in between, and for this part of the motion, Vi is what we are trying to calculate in part A, which we have got as negative 10.2. Okay, let's go to the next part. Now in the next part, it is asking us to find the total time of the fall. Total time, that means from the beginning till it hits the ground. Now for the last 40 meter, we have already got it as 2 seconds. We want to find for the top part of the motion. Okay, and we are just getting the information from the previous part that we found Vi here was, or the velocity here was negative 10. Okay, I've just written that in the diagram. We want to find the time for the top part of the motion. We are going to use the formula, which is the first equation of motion, Vf equal to Vi plus At, and focus on the top part. Look at Vi and Vf for the top part. If you look at Vi, it is 0, and if you look at Vf, it's now negative 10 meter per second. You can easily see that this negative 10 meter per second is the initial velocity for 40 meter. That means for the downward part. For the second part, this negative 10 was Vi. Right now, we are looking at the top part, and therefore for the top part, this negative 10 is now going to become Vf for the top part. So for the top part of the motion, Vi is 0 and Vf is negative 10. Knowing this, we can substitute in the formula. We know that acceleration will be negative 9.8 as usual because it's the free fall, and we get the answer approximately to be 1 second. But that's not the end of the answer because we want to find the total time. So this 1 second we have to add with the 2 seconds. So you can see that 2 seconds is for the last 40 meter and 1 second is for the top part. we have to add that and we get the answer as 3 seconds.